Everyone all right? Good day so far? So this is going to be a quick top-level overview of the cost bill of materials. We're going to go over a couple of things to start off with, but we're going to try and get onto the tool, but we might do a worked example sort of live as we go through it all and go from there. So topics we're going to go through: detailed bill of materials, costed bill of material, explanation file, supporting material, and then eventually we'll go on to some examples, and then maybe we'll do a worked example with you guys. You can do it, and we'll sort of discuss it as we go. So step into it. So my name's Oliver. I FS History, won it a couple of times, which was great fun. Now program engineer and advanced engineering programs department within composites and motorsport and all sorts of other things. I work part-time as a hydrogen systems engineer, which is good fun. It's a different way of looking at sort of renewable energy and fuels, and obviously and a cost judge, hence sat here talking to you. So first is the detailed bill of materials. So hands up in here who's former student class. Cool. And hands up who's concept class. Cool. Right, so we'll start with concept class. You guys don't have to do the full detailed bill of materials of the whole car. We'll talk about your stuff when we go into the costed bill of materials, but it's important to listen to this so when you move into former student class, you have a good idea. So a detailed bill of materials is every process, material, fastener or tooling used within your vehicle. Everything. We want to see the whole lot. The idea is we want to test your manufacturing understanding. So at this point, you're not adding the costs in. This is just to show us that you know how to take a piece of billet all the way through to a part that you've assembled onto the car, or laminates, or whatever it is you're using for your vehicle. We want to know that you know that process. So this should include all of the systems. So I think there's the costed bill of material, detailed bill of materials broken up into 8 sections. So all of those should be in play. So if we move on to the next one, which is the costed bill of materials. So I think you've heard earlier from John that this year's sections are going to be frame and body as usual, and then powertrain. So there's going to be other videos which I think have been filmed today for more information on that if you're a combustion team, and if you're an electric team, I'm sure there'll be more information on that as well as we move forward. So for concept class, you'll just be doing frame and body. You don't have to do the 2 sections, so it needs to be all the costed processes for that. So this is the report that should show every section of every cost of every part. You don't need to show your assumptions in this part, that will come later on. So this is a sort of top level view of that, and there's videos online again to show you how to use that one, and I think there's another video coming out later in the year as sort of a masterclass on that. So the explanation file is probably one of the most important files you'll do the whole time. This shows you shows us, the judges, every assumption that you've made all the way through. So it's going to show us your direct labour cost, it's going to show us the hours that you've worked, you know, shows the industry style for that. We need to know what your indirect costs are. So what are your overheads for the company that you're using, but you're costing it as if you are in industry. So past that, we go into the scalability side of it. So within this document, you might get asked within the event, how would you change your manufacturing processes if we wanted 100,000 cars? You've done it at the moment, so it's 1. You're making 1 car. There's very few industries you're ever only going to make 1. So within the explanation file, show about scalability. Try to understand what processes would change if you're going to make 1,000, 100,000, a million plus. It obviously is going to change massively. So your skill level, employees, direct costs, indirect costs are all going to change. So this document doesn't have a set format. You can kind of do it however you really want to do it. You know, we don't want 500 pages, we don't want 2 pages. There's a happy medium somewhere in the middle, and make sure it covers all bases. It needs to show the judges that you understand what you're talking about, and it's also something for you to reference in the event. So if we go, have you considered sustainability? You can go, yeah, it's there, and show us these pretty things and how many trees you would have to do to you know, cost back your car. You know, put everything in it, make sure it's all there. So the one that's the easiest mistake to make is this top line. When you do your supporting material, which is for FS class, make sure it's all your technical documents that are in the detailed bill of materials, all of them. They don't necessarily have to match up with the numbering system you get onto the cost bill of materials itself, but make sure they're noted on there so at least we can find them easily. But it's a single A4 PDF document. It can be as many pages as you like, but it's a single document, 1 upload. So there's lots of teams that get that wrong. There will be point penalties because it's said in the rules. I'm saying it again now. There will be points taken off for getting that wrong. For concept class, sorry, who was concept class again? Make sure you put renders in or snippets for the CAD model, because it's the only time we see your car at that submission date. So make sure you have them in there, so at least it gives us an idea of what we're looking at, because otherwise it's just a load of lines, a load of numbers, and it's difficult to picture it. But if we can see it, you go, okay, no, I understand why you've done that, and oh, that makes sense. So make sure you put renders in. So we're going to talk about a couple of examples today. We're going to have a look at a machined part, because I think on pretty much every car there will be something that's machined. And then I thought about welded assembly, because it's quite a simple one in comparison to carbon fibre layups and composites, because we'll try and keep it simple for the time being. We can, if anyone has a request to go through a certain system, we can do that at the end, and we'll do it as a group. So the machined part. So this is one I did a couple of years ago and thought it was quite good to showcase what sort of information you can get out of this. So not only is that sort of an okay amount of detail, it should, now looking at it, it should be down here somewhere, and it should be a damn sight better. But at the time, it shows enough of the detail. So it's not just what the material is, but what's the billet size of the material, what am I buying it in at, and how much am I actually using. So I've got a material cost already. So that's one part good. It's not the full material cost, it's my allocated, what I'm actually using. Past that, I've got the next step, which is tooling. You're not just going to throw it at the machine, you're going to have to put it in. Is that going to be soft jaws? Is that going to be a specific fixture for it? It has to be shown on there. If you've made your own tooling, it needs to go in there. So for this, it was just soft jaws, so I just clamped it in, and there's a cost associated to that. The next bit was I loaded the G-code in. So you may want to think at this point, you've got CAM software, CAM packages, you've got manufacturing engineers that will work that out. Toolpath simulation, chip rate per tooth, optimizing toolpaths. Oh, there's all manner of things you can get from that area, so that might want to be exploded further, but for the time being, that was enough for my level at that time. So when we go into the machining, you go into each operation. You're not just going to go, it's machined. That means nothing. We need to know the understanding behind that. Is it a one-op part? Can you do it in one go? Have you got live tooling? Can you do it that way? Is it a single fixture part, or halfway through this, we're going to have to turn the part over and then remachine it? You're going to rough it out first and then have a finishing op. All of these things need to be in there. You've already done that work because you've already designed it. All your designers in the team have gone, okay, we're going to do it this way, da, 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 da. It's just writing it out. You've already done it. You've done the work. You've just got to write it out. Last bit, and I say for all of them, you need to actually finish the part, deburr it, make sure it's done. You might put oil over the top of it, or you might package it, or you might have it a certain way if it's a fragile part. Make sure that's included. The benefit of writing everything down, the amount of time taken for each, the cost, the quantity, is you get those figures at the end. Okay, they're not laid out very well in this example, but I've got full material cost for that part, where in the normal cost of bill of materials I wouldn't have that. You've got the exact amount of time taken for each, so I know, can I optimize that? So the last bit is, how much did it cost me in wages for that? Because you're going to have a set labour rate for machinists, fitters, welders, laminators. You need to have that in your explanation file, because that's what builds this document. So normally, of a system, you don't get the maximum amount of money for that system. So I broke it down into parts, as you can see there. I know this one got it up the top as well. But then I know where my budget is going for each part. So from a Formula student perspective, if I got rid of all of these labour rates and just kept the material cost, and I had the equipment for everything else, then I know how much that parts cost me as a team member. Where I put industry based, I have all of that information as well. So this document can kill two birds with one stone. The other part is you've got total material cost. So when we go, how much did you spend on material this year? You can go, boom, it's that, easy. The next one is you've got cycle times per part, per assembly, and per vehicle. So one of the questions it might be, and I know John Connolly uses this a lot, how many working hours did it take to manufacture your vehicle? It's a really difficult one to try and actually work out, whereas this document actually does it for you. And it's easy, and it's already there. So the other bit is your total direct cost, is how much are you actually spending on wages per year as well, because you need to know what that sort of money is when you look at operational costs. So quite a basic part, I think it was a pedal. Really, there's more detail needed than that, but it's a good example. Has anyone got any questions at the moment on machined parts? Cool. Oh, good.
It's not actually about the machined part, it's about a little comment that you made. You said that you didn't think you laid that out very well. How would you say that that could be improved?
How that been? It needs more processes. So I forgot parts in that. So I could have had comments if I had it in my explanation file about how I was going to optimize the loading program to the machine. So the work that's also done in that. So at the moment I've assumed that I've got a memory stick and I've plugged it into the machine and that's given me the G code, where actually the work behind that memory stick could have been 2 or 3 hours, so I've lost that indirect cost. The way to get around that is I say that I've put X amount of percentage on top of this, and that's my overhead cost, and that's why it is. But that's what I'd add to that. Plus I'd probably put op 1, op 2, op 3, op 4, and make sure it's properly labelled out, because at the moment it just shows it as one operation.
Brilliant, thank you.
No worries, sorry.
If one of the processes isn't blended rate, and it's just a piece of machinery that's like you use a clap there, we usually assign like the whole time it's used as in process-wise, rather than assigning it how long it took to attach it on. So there you put load blank on,
yep.
And you put 1 minute. So would that mean that you've only used that blank, that piece of tooling for a minute now?
Well, no, so the next step above would show all my tooling cost. So I'd have X amount of tooling and fixtures that I've used for the bottom of those operations, so I might do that as a separate part and then using it for that amount of time. It's not the time of the tooling, it's the time of the person loading the tooling. So the tooling would be a separate cost away from the part. Sorry.
When you're talking about total direct cost, would you also include costs, say if you're prototyping something, that would be also included into that part and the time taken in that prototyping?
So adding prototyping as a cost as well. So I'm trying to repeat the same one. Yes, so you could absolutely add that to your cost. So obviously for the cost of bill of materials, the judges aren't particularly concerned about the overall cost of it. You're not getting scored because it's too expensive or it's too cheap. It's about the understanding. So absolutely, if you feel like you've had to be able to prototype something first to prove it out, that is a cost, and that is something that you've had to do. So yeah, 100%. Yeah, and I think it shows another level of that understanding. So yes, absolutely. Any other questions at all? Let's move on. So we're looking at assembly. So this is 2 separate ones that I've merged together. So this is just frame and body. Obviously underneath here there are pages and pages and pages and pages of prepping tubes. Each tube is a process, labelled them all out. So this is just very, very top level. It's just the front frame and front jigs for it. So there's obviously an assembly onto the jigs as well, and blah, blah, blah. So it's really trying to go into as much detail as you understand. And if you don't understand it, don't put it in because you get questions on it. So deburring and cleaning all the tubes prior to doing that. So, okay, it sounds like a really easy, really short time usage. You brush it off a steel brush, clean it up with some acetone. How many tubes are in a steel space frame? Add all that up, that's a significant amount of time. For one car, okay, you can kind of go, oh, it was an hour and a half we do to clean it up. So not a huge amount of time, but if you're scaling it up to 100 cars, 1,000 cars, whatever, that's a substantial amount of time, substantial cost. So things like that, add it in. So one of my materials was a litre of acetone. So although it's a little cost, and actually I'm only going to use a little bit each time, I need to add that cost in. So remove all oil and grease from the surfaces, again, so it's a hand finished process. And again, just being able to clean them off with a stainless steel brush. So the next bit as well is add your consumables into the detailed bill of materials and costed sections. So, you know, we're not expecting you to go and make your own welding wire or your own nuts and bolts and washers and things like that, unless they're obviously specialist, but add them in. They are, you know, when you add up one chassis, you get through quite a bit of welding wire. When you have 100 chassis, you get through a lot of welding wire. So make sure you add that in and have your price per kilogram, price per length, whatever you're buying it in at, whatever your conversion rate is, add that in. Again, fixtures and tooling. So this would be based up on setup time. The actual cost for those would be higher up. There's another section that says this is how we manufactured the tooling, and how that was all then assembled. And this is just assembling the tubes into that tooling. So I think there was a question about that earlier on. The other bit about welding, and there's parts missing in here that there should have been another section, is you're not just going to weld it all up in one go. You're not just going to go, we're going to seam weld that one, you're never going to do it. You're going to tack them up, and then you're going to do heat affected zones. You might do this bit and then that bit and then round to make sure it doesn't all deform. So make sure you add that in. So adjustments, allow it to cool, straighten if needed. You might scan it, you might have a jig that allows you to see that. The other part is adjustment at the bottom, so you're doing it again. Lower than that, you're also going to have inspection, which is something that was added on the very top level of all of it. So you might do dye penetrant testing. Make sure that, you know, welds are actually going to hold together when you go around the track. You might do destructive testing. You might just scan it in and compare it to the CAD model, but make sure there are some sort of inspection process. You may not do it at the university, but if you're going to do it in industry, there's going to be inspection. If you go into aerospace, there's going to be first article inspection reports. There's going to be something that shows that it is actually fit for purpose and it can be used. So put it in there. It costs time. And inspection does take forever, as you find out when you get into industry. So any questions on the assembly side of it? Okay, who's having a space frame? Who's going for space frame this year? Who's going for composites? Oh, so come on then. How are you going to go for composite chassis, full composite chassis, carbon fibre? Yep, so that's going to be a massive section because you're going to need to go into lots of detail for that side of it. I think we've spoken about that. Yep, whatever the laminate is, so yeah, there's going to be big sections in that as well. So this will look completely different to one for composites, but yeah, it will be an interesting one. Make sure you fill that out at the same pace. So, tips when you're writing that. I think every judge today has told you, read the rules. But read them again, read them again, read them again. You really do need to know them off by heart. The next bit is, and sort of self-promotional I suppose for everyone here, is watch the videos. There are 10 videos on how to cost online at the moment. One was dropped this morning. There's 5 more planned over the next sort of 5 or 6 months. There's one being filmed now. So make sure you go and watch them. There's some really good information in that. There's some really useful tips and tricks. Just watch them. There's also a few from 2014 on the iMaker YouTube as well. There's some really good points in that for some older judges or some slightly younger looking judges that might still be here. There's some really good information. So make sure to watch them. Take your time. It's never going to get done overnight. You saw 2 examples. That report was 40, 50 pages long. It took me months to sit and write it and actually work it out and make sure I had all my assumptions right and have all the costing side of it and all the additional information, sustainability, scaling. There's so much to consider when you're looking at cost. It is not just taking your wallet out and paying for parts. There's so much to consider and you really do genuinely need to take your time. The other bit is, and it sounds counterintuitive, but keep it simple. Make sure that you have a plan. The more assumptions you make, the more you have to remember when you go into the event or when you have to try and defend your documentation. If you keep it simple, you'll remember it. So if you've got a million different assumptions, you're never going to remember them all. You're going to get caught up on one of them. So just keep it simple, take your time, start early. There was a piece of advice I got a few years ago from a judge that says, panic early. That's it, that's the main rule, panic early. So the event, do the same thing. So tips at the event, again, read the rules. There are certain rules for the event. We had a team last year who didn't turn up with their car for the cost event and they paid the price for that. Car must be there, you must be there on time. If you're not on time, you are going to lose that time. We're not going to bolt it onto the end. Make sure you know the rules off by heart and know your documents. You're going to have stacks and stacks of paper because you've got to print them off. You've got to have your cost bill of materials, your explanation files and your supporting material at the event. It's a lot of paper. If I go, show me your wishbones, you've got to try and find them, know them. Either use sticky notes or use tabs or whatever it is, or just know where that information is. But any additional material you've got as well, make sure you know how to navigate them, with relative ease, and you practice that. Practice your presentation skills. So Formula Student can be quite a technical challenge. You've got a lot of design, there's a lot of real technical knowledge that you need to know. But actually when you get to the event, you've got a year's worth of work that you need to try and convince someone that you know what you're talking about in an hour. So really make sure you learn how to present. There'll be people at your universities that teach that. There's countless millions of videos on YouTube on how to present. Make sure you do it. Make sure you guys present in front of your team members. Your team members present in front of you. Not only is it a fantastic skill to have when you get to university, and I wish I'd started earlier, and I'm sure you wish I'd started earlier, that actually it will come in so handy later on down the line, and it's so easy to do it now. A couple of hours a week, a couple of hours a month, but it will make the difference when you stand in front of a judge and you are able to present clear, precise information with documents that you know really well and rules that you know better than anyone else. You'll smash it. Biggest thing is if you are talking to a judge and you're not sure, A, don't try and lie your way through it, but B, secondly, ask the question. Don't go, oh, I don't know. Go, I don't know that now. Could you help me out? What should I do? How was the best way to tackle this? And learn from them. There's people here that have been doing it for years and years and have been in industry even longer. So really do take the time to sort of learn from them. So that's it from a presentation perspective, and thank you ever so much for listening to me waffle on. But do you guys have any questions now, or would you like to do an example together sat in the room? Go for it.
Once we putting in the design elements that we put in, so obviously you put the time that you've taken to manufacture the car, but would you put the time in that we've done designing the car, things like that?
Yeah, I mean, it should go into the explanation file. Yes, absolutely. I mean, unless you guys are very happy later on in life not getting paid. Because at the moment you're all free labour and it's wonderful. It doesn't happen when you leave, unfortunately you can't do that. So yes, 100%. So I've seen teams before do it as like apprentice wages, but I don't think it's overly representative. So do it, yeah, work out exactly how many hours you would normally work in that. Make sure it's reasonable. I know people in here are going to work 16, 18-hour days and burn yourselves out, and you know, that's former student shouldn't happen. But put down average hours, 9 to 5 or 7 to 4, whatever it is, and work it out. What would you pay a mechanical design engineer? What would you pay an electrical engineer? And work that out, because it'd be really good understanding-wise for what your direct costs and indirect costs are and being able to compare them. So yeah, I would. Yeah?
When you've got like the chassis tube example you went through, that's a repeat process. Can you just quantify that one item, if that makes sense?
So let's go back to that one. So yeah, so as you can see on here, I've got frame welding front, because it goes on forever. So you can do frame welding middle, rear, but then obviously you've got tubes. So the big thing to remember is not every tube is going to be the same length. So you need to make sure that you've got quantities and costs for every tube. So I think my first year we did it and we just put tubes cut to this length, cost blah. You kind of get away with it, but it's kind of a bit of a cop-out, because actually the material length is going to change. That one might only be notched in one direction. You know, are you hand notching, are you laser notching? If so, if you're laser notching, not so relevant, it's okay, but if you're hand notching them, that's more time dedicated to do it. However, a recent addition to the costed bill of materials tool itself is that you can copy and paste and just change the information. So tubes, just put one in, copy it, the whole process, change the length, copy it, how many notches, change the length, how many notches. Excel is your friend with that. Any other questions, guys?
How much detail is too much detail?
That's a question for you to answer. There's a fine line. So for the explanation file, the detailed bill of materials, the cost bill, all of them, supporting material, we don't want 3 pages and we don't want 3,000 pages. There's a fine line. So best thing to do is write your reports or have a draft report, give it to another one of your team members and see if they understand it. If they don't get it, we're looking at it blind. They know your car. We're looking at it, you know, we see a picture, reports, explanation files, so we will go get it eventually, but the more, keep it relevant is the biggest thing there. But yeah, that's something for you to answer. There's a sweet spot, you've got to find it. Sorry, there was a question somewhere at the back.
In terms of design and R&D, I know in previous years it's optional whether if you want to include design and R&D, but with design and R&D it's quite subjective. You could easily spend 10 hours designing something and spend 150 hours on another thing.
Find a better designer. So if you've got a designer that can do it in 10 and 150.
Would you like to explain that in the cost explanation file, how long you spent on particular parts?
That should just be a number.
Random number?
No, not random number. It should be a number. You've spent an amount of time designing that part. If that's how much design time you spent designing that part, that is a number. It's not subjective then, is it? You've spent that much time doing it. Tell us that much time. Yeah, sorry, I don't think I might have misunderstood. But you're saying that it could change?
As in real life scenarios, there might be a problem with one part because like another part of the car means that you have to redesign the car.
Ah, okay, so engineering changes, etc. you can have on there. Yep.
So you can't just say, oh, it takes 2 hours to design.
Yeah. Widget, whatever it is, yeah. So you could have engineering design changes, it happens a lot. So if you have a set amount for engineering design change. So if a company rings up, you've got a PO coverage for something already, they want something changes, great, there's a minimum cost of £500, or whatever you want to put on there. So just put design changes or contingency of design change, whatever it is, or concession change, whatever you want to call it. Question at the back, I think. Same question. Oh, spot on.
If you found a mistake that had been missed, say, in the design process and it comes up in the manufacturing process, would you count that towards like a separate thing, or would you add that onto everything else like an explanation? And then you'd obviously take that out if you're scaling it up, because those wouldn't happen when you built your first one, your first car. But would you keep that separate, or would you like add it on to, like, say, for the front, for this scenario, the front welding, the frame welding on fronts? Say when you're putting the tubing together, something's been cut wrong, you have to then take the time to fix that. Yeah. And then that's obviously going to increase your time. Would you put that separately, or would you put that in that part?
Oh, that's a lot of detail. It's something you could add to your explanation file and say that there's a contingency of this for R&D. I suppose the thing to do is you're only making one. So you're right, this is an R&D style project, you're only making one, there's going to be fettling, there's going to be bits needed, so you could have a contingency and an explanation file for that to say, we know we're going to have to fettle all of this, so when we start looking at filing bits down for that, you have a separate cost, but you know, like you say, when you're going to go into scalability, you've done all that in 1 to 10, and hopefully 10 to 1,000 is set. It is something you could add, yeah? Would be an interesting point to discuss with the judges.
So would it be something we could penalise for, or would it just be like explaining why this one costs a bit more?
It wouldn't be something you penalise. If you've gone into that level of detail, I don't think you're going to get penalised for that. Yeah, I think that's...
I think you get more points for that.
Yeah, yeah, I quite like. I hadn't thought of that. I'm going to write it down now. But yeah, no, that's an excellent point. Any other questions? We all good? Cool. Okay, what are we doing for time?
You've got 5 minutes if you want push to 10.
We can push for 10. So, okay, final questions, or we can do sort of discussion panel for it. Okay, let's do it. So, has anyone got a part at the moment that they're thinking, I don't know how we're going to cost this? So, just let's talk about a part. Anyone give me an example? I quite like the idea of your chassis, actually. So we do a full composites one. So should we go for a full composites panel and go for that way instead of a whole chassis where you're going to have big ply books and God knows how many plies are sat within it. So how would you then go about costing your plate? So we're going to say you've got a flat plate, we're not going to say you've got a full chassis, so let's go for that. So where would you start?
Probably start with patterns and molds as a starting point.
Yeah, so we're going to go pattern mold part or pattern part. So if we're going to go scalability, we'll go pattern soft mold, hard mold.
Yeah,
Okay. Soft mold, so up to short runs. We're not going to go further than that. Okay, so let's go next.
On like the material for the pattern block first, and you have the machine process, machine the pattern block.
Yep.
Then you make the mold out of the pattern. This is kind of all the tooling stuff.
Yeah.
Then you go down to the composite level itself. Then again, have the material for the plies, just the carbon fiber. Then have more like the breather layers, the butyl plies, carbon, the nylon layers, and all that stuff. Then have again just all the manual layout processes, debulking, debagging, and then curing time, and then post-processing.
I think I'm done. I think he's got my job. Done. Finished. Well, yeah, congratulations. You're now the cost judge. But yes, exactly that. If you can go to that level of detail, debulking, especially what you're going to do with bagging it and then going to the cure side of it as well. One of the things to ask as well for the epoxy side of it, do you pay for delay essentially? If you've got something that's curing or something that's drying, are you paying for that time that you're not being able to work on it? That's a question we'll leave with you guys. If you've got one final question, other than that, I've got to wrap it up, and we shall. Okay, don't wrap it up. We'll carry on with that then. Okay, so who's first time cost event? Have you all done a cost event before? Your first time cost event, you'd be fine. The rest of you, really, have you all done one before? You all did last year's? Everyone virtual? You before online? Christ, okay, cool. So you guys are going to be fine then. You've had all these videos, you've got all of this stuff here, so you're all going to win. There you go, done. Awesome.